Hi, welcome to another edition of Moment of Science. I'm Cameron Sahami.
And I'm Kachun Yu.
And today's topic is Comet Hale-Bopp and comets in general. And Kachun, could you introduce our guests, please?
Well, our guests are, we have two of them today, which is a rare occurrence, but closest to us is Mary Urquhart and Niescja Turner. And both of them are researchers at the Laboratory for Space, or Atmospheric and Space Physics. And they've done a lot of education related stuff with astronomy, including a nationally syndicated appearance on News for Kids, which went out all over the country, and the topic was on comets. Which
I believe that was on another network.
Yeah, another network, not this one. Yeah. And they're also co-conveners of the Educators Workshop on comets, and they're also astronomy outreach coordinators at Fisk Planetarium on campus. So
welcome to Moment of Science.
Thank you.
And well, today we're going to start out just by talking about comets in general. So first question is, what are comets?
Well, comets are similar to asteroids in that they're pieces of material left over from the formation of the solar system. Where they really differ is comets have a large ice component, and by ice I mean water ice, but also ammonia ice, methane ice, and various other ices.
So normally when you think of ammonia or methane, these are gases in our environment on the Earth.
True, but comets originate in the Oort cloud, which is actually very far from the inner part of the solar system. And far from the sun, there's no problem with these ices, or with these gases that we think of gases being solid, just because it's so cold.
So they're primordial. They've been around for a really long time.
Exactly.
They're not something that's just recently formed and so on and so forth. I think there's a tendency to think that comets are kind of recent discoveries, or when you find a new one, it's a recent thing, but they're just some of the oldest stuff out there, right?
They really are some of the oldest stuff out there. They seem recent because they enter the inner solar system so rarely.
Great.
So why are comets important?
Comets are important because, being that they're these primordial pieces left over from the formation of the solar system, they can help us learn about what the early solar system was like and the material out of which the solar system formed, including the planets and the sun.
Yeah, it seems like there's been a lot of comets around lately. There was Hale-Bopp or Hyakutake and Shoemaker-Levy 9. Is there something special going on lately that we're seeing all these comets, or has our instrumentation just gotten better, or what exactly is the deal?
Well, in some ways, the instrumentation has gotten better to allow us to see things. But comets are also, usually you only have spectacular comets come through Earth's skies, maybe a couple times a decade, and a really spectacular comet maybe once a century. We're actually very lucky to have seen Hyakutake and now Hale-Bopp in our sky about a year apart.
So what are comets made out of?
Well, comets have, the hard part of a comet is a nucleus, and that's typically on the order of 1 to 10 kilometers across. Hale-Bopp's nucleus is special because it's actually very large. They can be as big as about 100 kilometers, and that's very rare, but Hale-Bopp's is probably 25 to 40 kilometers across. And Niescja is going to tell you all about what actually is in the nucleus of comets.
Yeah, actually, I have a little demonstration that I like to do with kids, and this maybe is a fun thing for families to do.
Oh, great.
Where we actually make the nucleus of a comet.
So this is something the kids could do at home.
This is something the kids can do at home.
And actually, I think we have a CG for the comet recipe, too, so if we could bring that up.
Sure. Yeah.
And also, people can access our webpage for the complete recipe and on how to make comets, if you're interested.
Now, the sense in which we're making a comet is that we're putting this together out of things which are found in real comets. So we're going to use the standard ingredients, things that we really find in comets, and then when we get done, we should have something which looks vaguely like what a real comet would look like if you could get up really close to it. The first ingredient is the most common, most prevalent ingredient in a comet, which is just water. So we put in about 2 cups of water into our little mix here.
Now, it looks like you're making that in a special bowl. What's going on there?
Oh, this special bowl, this
or?
is just a bowl with a bag in it so that I make less of a mess.
Oh.
If you don't use a bag, you're really in for a special treat in your kitchen, so I recommend that you line this with grocery bags of some sort. And the next ingredient is just dirt. Now, dirt is supposed to represent sort of ground up rocks and dust and things that we find in comets. So you just put a couple tablespoons or so of dirt. Then you kind of stir it around, and it starts to get a little yucky.
Maybe we can get a shot directly into the
Yeah,
bowl.
if we could get a shot in the bowl, that would probably be useful.
Oh, what exactly is that?
This is sugar. Now, we don't actually find sugar per se in comets, but we do have simpler things than sugar, which are made of the same kind of stuff that sugar is, simpler, what we call hydrocarbons. So I just put a little bit of sugar in here.
Yum.
Yeah, this is pretty
It's a Mai
tasty.
Tai, ready to go.
It's about to get a little bit less tasty, actually, because the next main ingredient, or the next ingredient that we find in comets, is ammonia.
Oh.
So, just some common household glass cleaner, and a couple of squirts. Makes your comet nice and smelly, as well as
Wow.
more scientifically
Maybe we can tilt
accurate.
that forward
If we can
so
just
the
tilt
kids
it
can-
forward and look.
Yeah.
can't
Boy, that's
see too
looking
much
awfully
yet.
dark. You think of a comet as being this bright glowing thing.
Comets are actually very dark. They're called dirty snowballs very often. They're lots of ice and lots of dirt. And then the last ingredient, and this is the fun part that the kids really enjoy,
And this is why you're wearing gloves.
and this is why I'm wearing gloves, I should point out. You want to wear gloves when you're handling dry ice. So the next ingredient is dry ice, which is just frozen carbon dioxide. And you want to get about maybe 4 or 5 pounds of it and let it sit out for a day so it warms up a little bit. It can be a problem if you have dry ice that's too cold. It makes everything just freeze up too fast. So not to part your dry ice. I have it in a bag here, so I'm trying to make less of a mess.
Kids might want their parents' help with this part.
Yeah, you may want to ask your parents to help you out there.
Yeah, I don't recommend that young children play with dry ice unsupervised.
Or with hammers either.
Or with hammers.
Probably jab yourself in the eye with the spoon, too.
Okay, so then you just take a couple of handfuls of dry ice, using your gloves, of course, and dump them into your comet.
Whoa.
All right, here's the fun part.
Yeah.
See if I can tilt that forward so that,
Yeah, so the first thing it's going to start to do is spill over, and this is, of course, just carbon dioxide. Well, you breathe it out every day. It's not going to cause too many problems.
you can hear it boiling in there.
You can
It's quite
actually
the
hear a
brew.
bubbling if you get close enough and it's quiet enough. And that's just the fact that the carbon dioxide is changing from a solid to a gas. It's sublimating, and that makes little carbon dioxide bubbles in the water.
Wow.
So we can hear
Carbonated
that a bit.
comets. So the carbon dioxide is just basically cooling your mixture. That's why it's there?
Well, it's there because, one, we find it in comets. We find frozen carbon dioxide in comets. 2 is that it's going to cool our mixture and give us water ice. And 3 is that it's subliming, it's sublimating. It's changing directly to gas, which is what we see real comets do. Right? They get close to the sun, and the sun's warmth heats them up, and we get all sorts of gas and then eventually dust kicked off. And that gets blown into a tail, right? So, next thing you want to do is take your comet and put it together like a snowball. So you kind of got to hold it and mash it together a little, and it's a little messy.
Wow.
And our comet could use a touch more of this.
So it's sort of congealing together now?
Yeah, so what it's doing is
this
this is just the dry ice freezing the water, and so it's going to kind of pull together into more or less one cohesive lump of comet, one big dirty snowball. Okay, it's almost there. All right. So, then if we can get a shot of it.
If we can tilt that forward.
Can we-
Wow, there you go. Comet right there in the studio, kids.
Yeah, so what you see here, can we get a zoom in on this? Yeah, that's good. That's good.
Well,
So
that's
what we
pretty
have is
disgusting
just this dirty, lumpy, rocky snowball with dry ice and dirt and sugar and ammonia.
Wow.
That's sort of subliming off. And you can just imagine with all this stuff coming off of it, that with a nice breeze from a fan or your breath, or later we'll talk about the solar wind, you can make a nice comet tail.
Wow, so that's why a comet looks the shape, it has the shape that it does, you know, the ball and then this giant tail. It's because there's some kind of wind out in space blowing it?
Yes, there's actually a a high-speed gas of charged particles that comes out of the sun. It's coming out with the light, and the light and the gas together push back the material into a nice long tail. So a comet tail is always going to point away from the sun. It doesn't trace out the path of the comet or anything. It's always away from the sun. And we have a little demo, I guess.
Let's move this out.
You have to remember that the reason this gas is so powerful is that it's moving so quickly. We're talking about something which is moving at 450 kilometers every second. That's about a million miles an hour.
Wow.
That's incredibly fast. It's 280 miles a second. So comparatively, a comet's moving rather slowly compared to the solar wind. So what you have, we can turn on our solar wind. This is going to represent the sun. This is our solar wind. So if you have a comet coming towards it, then the tail moves away, and we're going head first, as you might have suspected previously. But if a comet's moving away from the sun, it goes tail first.
Ah, wow.
Okay? And so this fan demo sort of helps you visualize the fact that, yes, comets really can move tail first or sideways with respect to the tail, or whichever way. And it's all just this gas and light from the sun that's pushing it back into a tail, and not some path.
But aren't there different parts of the tail, too?
Yes, there are. There are two main parts, and we have a picture if you want to hold that up.
Wow, now, that's not Hale-Bopp, is it? That's,
No, you're very good. That's Comet West. And what we see here is this blue streaky thing right here.
Can we get a shot of this, please?
Can we get a zoom?
Camera 2, camera 3. Oh, there we go.
Oh, here we go. Okay. So this blue streaky tail right here, this is what's called the plasma tail or the ion tail. And that's the tail that is almost totally, that's made of charged particles, and that is pushed back directly by the solar wind, this gas coming from the sun.
And what about this big
And this big
furry
bright tail, this is the tail that you mostly see when you go out at night, and that's the dust tail, and that's more pushed by the radiation pressure of the light coming from the sun.
Ah. And why aren't they both in the same direction?
Well, the solar wind is a much more powerful shaper of comet tails than is the light. So this one is going to point directly away from the sun, and this one's not quite directly away from the sun. We get a little bit of effect from the motion there.
Wow.
Okay.
Get a fan shape actually in the dust tail. It has to do with
it
particle
does look like it
sizes.
spreads
The
out
smaller
a
the
bit.
particles and larger particles are separated into a fan shape.
Wow, it looks like there's maybe 2 or 3 distinct peaks there. So that's a sort of a particle size distribution
Yes,
across
it
the
is.
tail? Wow.
It's sort of a sieve or sorter
Wow.
of particle sizes.
What I'd like to do is now show the size, scale of a comet.
Boy, we got all these really great comet props.
That's what happens when we do education.
You bring more educators
So-
and you have more props.
What I have here
Okay,
is
can you
the
stand up?
nucleus of a comet, as we already mentioned, is very small. So I'm going to represent that by a tiny, tiny dot, the smallest I can make, which is probably not even going to be visible, in the center of this plate.
Okay.
It's going to represent the nucleus.
So that's the nucleus. And what is the cup, or what is the plate itself? That's sort
This
of
is the coma.
glow?
The coma is the part of the comet you usually see when you see the head. It's actually difficult to see the comet nucleus. In fact, it's almost impossible when it's close to the sun because of the bright material coming off and forming the coma.
So the coma is made out of the same material as the nucleus. It's just gotten away from the nucleus.
Maybe a little less of the dust and a little more of the easily sublimated materials, the ices. This, for scale, it represents the Earth. I have a small candy.
Wow. So the coma is that much bigger than the Earth?
It certainly is. It can be about between the size of Jupiter and the size of the Sun. So a comet is actually,
That's a Skittle or an M&M?
it's a skittle, basically the same size as in a minute.
An M&M would work too.
Or a
Let's
Reese's
show the
piece.
tail.
Yeah,
The
Reese's
tail
Pieces
is the
would be
very
better.
impressive part.
Can I hold this one?
Sure. Am I going to be the ion tail or the
The blue
particle
tail represents the ion tail, which usually
Okay.
has a slight bluish tint to it from fluorescence. And the
Ah.
white represents the ion tail.
All right, so how long is this going to be?
The clumsy tail, I think.
The scale, 75 feet at this scale, is about the same as the distance between the Earth and the Sun. And a comet can be the comet tail, by the time the comet reaches the Earth's orbit, can be 1 to 2 times that length.
Wow, I don't know if there's any way to physically show this in the. I guess we
No,
could.
but
Yeah, I think we can stretch it around and
Yeah, I was going to chuck one of these.
go ahead.
Here goes the ion tail.
That was the dust tail.
Oh, that's the
Dust
dust
tail, that's the ion tail.
there-
So as you can see, the comet tail is significantly larger than the Earth. And it all
Wow.
comes from such a small, tiny, solid piece. So it's made out of very, very little material.
Yeah, that's really amazing, considering the Earth is skittle-sized compared to this. So when you're talking about 87 feet in comparison to the little Skittles?
Yeah, these three
Wow.
years are. The actual number for the distance between the Earth and the Sun would be closer to 75.
Now, when you're talking about a tail this large, isn't there a chance that the Earth can easily pass through the tail? Or
Yes,
within
it
the
can.
comet?
And in fact, for comets that come by the Earth often, which are known as short-period comets, we actually have what's known as meteor showers coming from debris left by the comet when the Earth's path crosses where the tail went. You're going to have debris, dust-sized debris, entering the atmosphere.
Okay. Well, you mentioned short-term and long-term comets.
Yes.
Can you talk about what the difference is between those?
Short-term comets are comets with a period of orbit that's usually less than 100 to 200 years. Halley's Comet is an example at about 76 years of a short-period comet.
So these comets keep returning back
Right.
to the
Yeah.
inner
So
solar system.
Hale-Bopp, is that a short-period comet?
Hale-Bopp is actually a long-period comet. It originally had an orbit that was probably about 3,500 to 4,500 years long.
Wow.
It had an encounter with Jupiter recently that shortened its orbital period, and now it's about 2,500 to 3,000.
Wow, so we won't be seeing that comet in our
This is
lifetime.
your last chance.
Wow.
But compared to Hyakutake, which had a 50,000-year orbit, it's still a relatively
Wow.
frequent visitor to the solar
So the
system, the
medium
inner
length
solar
comet.
system.
So do long-term comets turn into short-term
They
comets
can
eventually?
through gravitational interactions with the planets, but it's actually not a very common occurrence. For instance, the shortening of Hale-Bopp's orbit, but that still didn't shorten it enough by any means to make it
Well, what are the odds of collision? Like, that was a big thing in the news last year when Shoemaker-Levy 9 actually hit Jupiter. And there were some people, I guess, maybe Carl Sagan was among them too, that were sort of brought to people's attention this idea of possible collisions with the Earth, of either asteroids or comets or something like that. I don't assume that's something that's very likely, is it? Or
Actually, it's not very likely. Statistically, collisions like that don't happen very often. But of course, it can happen. The Earth's path is often being crossed by asteroids and by comets. Chances are it won't ever happen in our lifetime or the lifetime even of civilization unless we have a very long-lasting civilization.
wow,
Okay.
well, something to look forward to, or not look forward to, I guess.
All right, well, let's see. You have a picture of the comet's orbit.
Yes, I think this is significant. I have a picture of the life cycle of a comet.
This is a comet, or is this actually like Hale-Bopp?
This
or?
is just a comet. It's my cartoon. It's not to scale, which is very important. The comet nucleus looks far too big on this particular image. But what you may want to notice is the comet nucleus starts off very dark, and in this case, it's much bigger than it should be. It starts off very tiny. As it approaches the sun and gets past about the orbit of Jupiter, it starts to become active, and material starts to come off of it, and that forms a coma. As it gets even closer to the Earth, a tail begins to form. And by the time it's the same distance as the Earth from the sun, it has a pretty substantial tail, about the length of the one that we were showing earlier. And then this,
And you can actually see, well, the inner red circle is the Earth's orbit, and then the outer red circle is Jupiter's orbit. So by the time the comet gets to about where the Earth is, the tail is easily the size of the Earth's orbit.
right, exactly. That part I tried to do a little bit
Yeah.
more to scale. But also important is what Niescja was pointing out, which is the tail always points away from the sun when the tail is actually there. And it isn't, of course, actually there. For the majority of a comet's lifetime, it's just a cold, dark nucleus. It's only when it visits the inner solar system that we actually see a bright coma and tail.
Yeah, I think we just saw our phone number go by, so if you guys have any questions to ask our guests, please feel free to call in, and we can field some of your questions.
Okay.
Well, until people call, what I'd like to show you is a picture of Hale-Bopp, which is our latest cometary visitor to the inner solar system. Hale-Bopp is really a very spectacular comet. It's different in a lot of ways from Hyakutake. Hyakutake was very close to the Earth, and it came close to the sun, and so it appeared very bright. But as far as comets are concerned, it was actually very, very puny.
So this is the one that people can go out and see every night tonight, right?
Definitely. When go out to someplace dark in the evening, look in the northwest, and there's the comet.
Great. I think our crew is letting us know that we have a call. Could we go ahead and pipe that into the studio, please?
Hi, yes, I've got a question.
Yes.
I noticed that when you see shooting stars, they look like they're going a lot faster than the comet that's been out there. Are shooting stars just fast-moving comets, or what?
That's actually an excellent question. A lot of people are under the impression that comets and shooting stars are a related phenomenon. In a sense, they are, but not in speed. What you're seeing with shooting stars are little meteors coming into the Earth's atmosphere, and those are often leftover debris from a comet that came and passed by the Earth's orbit. But they move much faster because they're actually streaking through the atmosphere. A comet is moving quickly, but it's very far away from the Earth, even on a close pass, and so it won't appear to move at all in the sky.
Well, kind of like looking up and seeing like a jumbo jet. It's going like 400 miles an hour, but you feel like the car next to you is going a lot faster because it's closer.
Exactly, and the comet is just so much farther away that it seems to stand
Well,
still.
excellent question, caller. Thank you.
Thank you. Now, I believe you also have a picture showing Hale-Bopp's orbit.
Yes, I do. One reason why we know that comets do originate in what we call the Oort cloud, which is a spherical distribution of comets, or cometary nuclei that's very far away from the inner part of the solar system, is that comets come in at all different angles. For instance, Hale-Bopp is coming in, instead of being in the plane of the solar system with the planets, it's going up above the north pole of the sun and then dipping back down south.
wow.
So it's almost inclined 90 degrees to the orbit of the planets.
So the planets are orbiting in a plane along here, and it's doing this sort of up and down motion along there. Interesting.
And this, I believe, actually shows the location of Hale-Bopp.
On April 1st
Okay.
of this year. So why don't we show people, it's about how to find Hale-Bopp in the sky, although it's very, very easy to do. You don't have to do any work, you don't need a telescope, you don't even need binoculars. Just go out to someplace dark and look in the northwest when it's clear, and there's no problem.
I think we have another call. Could we go ahead and pipe that in here, please?
Hi, I was wondering how you know when the comet is going to be coming by and how you predict that.
Another good question. The way we predict that is by looking at the path the comet's making in the sky and determining its orbit. And once we have the orbital ellipse down, we know when it will return.
And as far as detecting them, you detect them with sort of long-range telescopes? Is that how they're found originally?
People do extensive sky surveys. An awful lot are found by amateur astronomers, and some are found by professional astronomers.
And if you find one, I guess you get to name you get to
Exactly.
name it after yourself.
So
Great. So let's.
let's see where Hale-Bopp will be in the sky.
Well, now we're heading towards the end of March, and I don't want anybody to be confused by looking at the star diagram that we have here, because it's extremely easy to find Hale-Bopp, and you don't need any sort of diagram. But this is just showing the relative motion of the comet against the stars, and it really illustrates how slowly the comet is moving. You'd have to take photographs hours apart, really, to detect much motion at all for this comet in the sky.
So again, for people who want to look, you have to
Yeah.
look towards the northwest.
Right.
Which is,
Yeah. Now, is that in the morning or in the evening or both?
It's in
or-
the evening that you want to look in the northwest. It's actually disappearing out of the morning sky. And soon you won't be able to see it in the morning at all. But in the morning, you want to look in the northeast.
Okay.
This comet is close to the sun, and so you'll see it just before sunrise and just after sunset.
So just over Mount Sanitas, right? Thereabouts?
So for those people who are interested in seeing the comet a little later, I also have a diagram of where it will be in April. What actually is going to happen is this comet is going to move through the sky and fly into the arms of Orion before it disappears from view in the northern hemisphere. And it's going to disappear from view by about May 10th. So
is that because it's getting further away from the sun? And
it's going toward the southern view. Actually, if we could go back to this particular illustration, the comet is going to disappear from our skies because it's heading too far south for us to see.
so you'd have to be in the southern hemisphere to see it.
But we get the best view. We get to see the comet when it's closer to the sun and closer to the Earth than the southern hemisphere.
Okay. That's great. So let's see. I think the one interesting thing that has popped up recently, especially over the internet, is that some people have believed that an alien spacecraft or a UFO was detected close to the comet.
Very glad you asked that. I just happen to have a graphic for that particular subject.
Oh, it's the Saturn-like object, right?
Saturn-like object. What happened is an amateur astronomer in Houston took a picture of Hale-Bopp. And with that picture, he saw this star, actually. But to him, he actually wasn't on his star charts. And so he thought that it was a UFO. And he called a local radio celebrity And before anybody knew it, it was all over the internet and even on national news that there was a UFO by Hale-Bopp.
Wow, so here's that infamous photo right there.
So what is causing this star to,
Well,
to have Saturn-like
It's
features?
either a diffraction spike or it's a CCD bleeding. And a CCD is very much like the chip you find in a video camera. And when you have a bright object, and this object actually isn't that bright, but it is when you add the light up over a long period of time, which is what this astronomer did to get this good picture of Hale-Bopp, that causes the light to go out a bit on the sides.
Okay.
And that caused that particular problem.
Wow, well, that's fascinating. We want to thank you for being on our show. I think they're telling us that we're out of time on our program. If you guys would like to learn more about comets, there's going to be links off the Moment of Science webpage to a Comets webpage and also to the web pages of our guests, so you guys can surf the net and learn more about it. June, do you have anything else to?
Well, I want to thank our guests, and also your Comet Educators Workshop also has its own homepage too.
Yes, it does.
And so basically, all of the recipes and demonstrations that you've shown us tonight will be on that homepage as well. So we will have a link to that. So once again, thanks a lot. Thanks for watching.
For joining us.
Oh,
And thank you, callers.